Friends, welcome back to my channel. So today we will be covering the CBSE board grade 10, the first chapter, that is real numbers. This is going to be the part 6 video. Already I have discussed the previous 5 parts of the real numbers chapter. So if you haven't watched yet, please watch it first, then come back to this video. Okay, so let's move into it. So today we are going to learn about the fundamental theorem of arithmetic. So though the name is bit big, but don't worry, this is very easy and very simple that you already know. This is basically the prime factorization, what you did in the earlier classes, like your smaller classes, the prime factorization of any number. So what this fundamental theorem of arithmetic states, first you need to understand that every composite number can be composed of as a product of primes which are unique. Okay, so every composite number can be, we can in every composite number we can think of a product of prime numbers which are the unique prime numbers. Okay, that is basically nothing but the prime factorization. Okay, so this fundamental theorem of arithmetic is just the prime factorization that you know already in your previous classes. So now if I asked you to find the HCF and LCM of 180 and 54 by using the fundamental theorem for arithmetic, it's nothing but you need to do the prime factorization of these numbers and then you need to find the HCF and LCM of it. Okay, so first we are going to do the prime factorization. So if we do the prime factorization of 180, we will get 2 into 2 into 3 into 3 into 5. Now, if we represent this 2, first we need to express this prime numbers product in terms of the exponent form. So since here we have 2 into 2, so that is going to be 2 to the power 2 into 3 to the power 2 into 5. Now similarly, let us represent 54. So the prime factorization of 54 will be 2 into 3 into 3 into 3. So now if we represented it exponent form, that is going to be 2 into 3 to the power 3. Okay, now how to represent the HCF and LCM? So HCF is nothing but the product of the least powers of the common prime factors of the number. So we need to check what that means. We need to check the prime factors of these two numbers which are common, and we have to take the minimum power from it. Okay, and what is LCM? LCM I will explain. LCM is just the opposite one. So we have to take the common one and we have to common as well as the uncommon part as well, and for the power part we have to take the maximums. I will explain that later on, don't worry. So for this case, what will be the HCF? Since 2, 3 and 5, if you take a look, for 180 there are 3 prime numbers, and for 54 we have 2 prime numbers, 2 and 3. Since 5 is not there in both the numbers, so we will not consider 5. We will only consider the numbers which are common, which numbers are common, which prime numbers are common between the numbers. So 2 and 3 are common, and for exponent part or the power part we will take the minimum one. So in first case we have 2 to the power 2, and in the second number we have 2. So we will take the minimum, that is 2 only. In case of 3, for 180 we have 3 to the power 2, and for 54 we have 3 to the power 3. So out of this we will take the minimum one, that is 3 to the power 2. So the HCF will be 2 into 3 to the power 2. So that is 2 into 9 is equal to 18. So this is the HCF. Now LCM is, as I already told you, that it is the product of the highest powers of all the prime factors of the numbers. So in this case we have to consider all the prime factors. For HCF, whenever there is a prime factor that is not common, that we have to discard. Okay, but for LCM we have to consider all the prime factors with the highest power. Now for LCM, if you take 180 we have 2 to the power 2, and for 54 we have 2. So in this case we have to consider 2 to the power 2 because that is the highest power. For 180 we have 3 to the power 2, and for 54 we have 3 to the power 3. So in this case we have to take the highest one, that is 3 to the power 3. And since 180 has 5, so we have to also include the 5 as well. So this is going to be the LCM. So now if we simplify 4 into 27 into 5, that is going to be 540. So this is the LCM. Now we know that LCM and HCF. Okay, so this is another thing, that LCM and HCF, I think you already have learned this in your smaller grades. Like if we multiply LCM into HCF, that is going to be the product of the number itself. Okay, so 18 into 540, that is equal to 9720. And if you do the product of these numbers, 180 into 54, you will also get 9720. So that's why HCF of any number A and B into LCM of the number A and B, that is equal to the product of the number, that is A into B. Now let us solve some problems. Express each number as a product of its prime factors. So now let us do the prime factorization of 140. So if we do the prime factorization, so here I think this is self-explanatory, I need not to explain it. So 140 can be represented as 2 to the power 2 into 5 into 7. Now the another number 156, we need to express it in the product of prime factors. So I am showing you step by step. These steps are self-explanatory, I don't need to explain it, I hope. So 156 is equal to 2 to the power 2 into 3 into 30. Now next we have 3825. So now let us do the prime factorization of it. Okay, so what we got, that's 3825 is 3 square into 5 square into 17. Now another one, that is 5005. Okay, so 5005, if we divide, we keep on doing it. Okay, so what we got, 5005 equal to 5 into 7 into 11 into 30. So here all the numbers are different, so we cannot express it in the exponent form. Now 7429. Okay, so in this case I know this is bit difficult to find because we have to find the prime factor for it. Till 17 you will not get anything. So you can try with this method, like whenever you will not getting, like you are not understanding how to find the prime factor, so you have to check always the unit place, what number is there. In the previous examples also, like 5005, if you take a look, that there is 1001. So 1 is there in the unit place. So first you try, because you have to find the prime numbers which has the 1 in the unit place. If you multiply with any number, 3 first you need to try. Since 3 is not divisible, 5 will not go definitely. Then try with 7. So that is fine. But for 1143, 143 is also easy, because you know that it will be easily divisible by 11. You can here, to find this, you can always apply for the divisibility rule first. I think you have learned the divisibility rules in the earlier grades, like divisible by 2, divisible by 3. 3 we can easily check for, like if we add the digits of the number, and if that number are divisible, then it is divisible by 3. The same rule goes for 9 also, but 9 we don't need to take, because 9 is not a prime number. Okay, so that way you can check it. 11, you know that we have to check the uh, odd positions of the number and the even positions of the number, and if we subtract that, and if we get 0 or a number that is divisible by 11, that then the number will be divisible by 11. Okay, so 11 till 11 it is very easy. Now after that we have 13, and then we have 17, right? So how do you check that? The way is like, if you take a look for this 47429, we have at the end we have 9. So we can uh, just till 11 we can check with the divisibility rule. After that you should try with the 13. Since 13 is not going, then we should check with the next prime number, that is 70. Now what about 437? 437. So first you check with the, like, till 11 you can check with the means, since in unit place you have 7, so you can try with 3 first. So 3 you can just use the divisibility rule, that is 4 plus 7, 4 plus 3 plus 7, so that is going to be 14. Since 14 is not divisible by 3, so 3 is not going to the prime factor. Then 5 is also not doing. Then 11 you should not check, because 11, if you can check 11 also, like 4 and 7, so that is 11, and the odd position we have 3, so 11 minus 3, that is not going to be the divisible by 11. Then you can use the 13. Then we should not check with the 17, because 17, in the 17 table, if you multiply with any number, that will not give you 7 at the unit place. So you should, then the next number you can check is, after 13 you can check with the 19. So in this way you have to do the trial method. Okay. So now for 7429 we got 17 into 19 into 23. Now next, these are very easy problems, it's not so difficult. Express each number as a product of its prime factors. So 1000, this is very easy. 1000 we can represent, now do the prime factorization of it. Okay, so 1000 can be represented as 2 to the power 3 into 5 to the power 3. Okay. Now express each number as a product of its prime factors, that is 72. Now let's do the prime factorization of it. Okay, so we got 72 equal to 2 to the power 3 into 3 to the power 2. Okay, so this is the product of the prime factors. Now next question is, find the LCM and HCF of the following pairs of integers and verify that LCM into HCF equal to product of two numbers. Okay, so first we need to find the HCF and LCM, then we need to verify that LCM into HCF is equal to the product of two numbers. So let us do the prime factorization of 510. Okay, so now 510 is equal to 2 into 3 into 5 into 17. And if we do the prime factorization of 12, that is 2 into 2 into 3. So that is 2 square into 3. So we know that to find the HCF, we have to consider the common factor and the minimal power. So 2 is common, so but we will consider only 2 because that is the minimal power over here, or the smallest power. Then we have to consider 3 because 3 is also common. And 5 and 17 we will discard because that is not a common factor between the two numbers. So HCF is equal to 6. So product of common factor raised to least power, that is the HCF. Now coming to the LCM, for LCM we have to consider all the factors and the maximum power. So here 2 is common between these two. So and we have to consider the maximum, that is 2 to the power 2. Then 3 we have only 1, so that is 3. Then 5 into 17. So that is 1200. So LCM is the product of all prime factors raised to highest power. Now the verification we need to do. So LCM into HCF, that is equal to, LCM is 1020 and HCF is 6. That is coming 6120. Now do the multiplication of the product of the two numbers. That is 510 into 12. That is also coming 6120. So we can say that LCM into HCF equal to the product of the two numbers. Now next question, we have same thing, we need to do it for 336 and 54. So let us do the prime factorization first. Okay, so 336 is 2 to the power 4 into 3 into 7, and 54, let us do the prime factorization. So 54 equal to 2 into 3 to the power 3. So now for HCF, we have to take the common factors, that is 2 and the smallest power. So here only 1. And for 3, so 2 into 3 only. Okay, that is 6. So HCF, we know that the product of common factors raised to the least power. Now for LCM, we need to consider all the factors with the highest power. So 2 to the power 4 into 3 to the power 3 into 7. So which is coming 3024. So LCM is the product of all the prime factors raised to highest power. Now the verification, that is LCM into HCF. So 6 or 3024 into 6 is equal to 18,144. Now we need to do the product of the two numbers, that is 336 into 54, that is also coming 18,144. So LCM into HCF is equal to the product of the two numbers, hence verified. Now let's see what the next question states. Find the LCM and HCF of the following integers by applying the prime factorization method. Okay, so this is very easy. We have to do the prime factorization of these three numbers. Okay, so 17, 23 and 29. If you take a look, these are all prime numbers. So 17 means 17 into 1, 23 is 23 into 1, and 29 is 29 into 1. So since in this case there are no common factors other than 1, so the HCF will be only 1 over here. Because we know that the HCF is the common factors raised to the power least powers. Okay, now for LCM, we have to take all the prime factors and raised to the power highest power. So here 17 into 23 into 29, we have to consider all these numbers, and no need to consider 1, because you can, whenever you are multiplying 1, you will always get the same number. So we got LCM as 11,339. Now the next question is 8, 9 and 25. We have to find the LCM and HCF. So now first find the prime factors of 8. 2 to the power 3 into 1. For 9 it is 3 to the power 2 into 1. And 25 it is 5 to the power 2 into 1. So here also, if you take a look, there is no common factors between these three numbers except 1. So HCF will be always 1 over here, and LCM will be 2 to the power 3 into 3 to the power 2 into 5 to the power 2, because we have to consider all the prime factors with the highest power for LCM. Okay, so LCM we got 1800. Now next question, we have to find the LCM and HCF of the following integers by applying the prime factorization. Okay, the same thing. So first we need to do the prime factorization. So 12 is 2 to the power 2 into 3, 15 is 3 into 5, and 21 is 3 into 7. Now HCF will be the common factors between these three numbers. If we take a look, there is 3 only common. So HCF will be 3 over here. And for LCM it will be, we have to find all the factors with the highest powers. So 3, since 3 is common, that we will consider only one time. Then to the power 2 and 7 and 5. So which is coming 420. Now next question is, given that HCF of 306 and 657 equal to 9. Find LCM of 306 and 657. Now here we have to apply the LCM and HCF equal to the product, that relationship. So we know that the relation HCF and LCM is equal to the product of the two numbers. So now HCF we know is 9. So and LCM we need to find out. So HCF into LCM equal to 306 into 657. Since we know HCF, so we just replace that value. So 306 into 657 by 9. So this is going to be 34 into 657. So 22,338. That is the LCM. Now the next question is, there is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Okay. So how we are going to solve this? So what is given that there is a circular path around the sports field. So let us consider the circular path. The sports field is the green one and the circular path is shown in with the brown one. Now let us consider this is the starting point. So the time taken to drive one round is for Sonia will be, so Sonia is taking how much time to drive one round? That is 18 minutes. Okay, so if we consider that for every round, so for first round Sonia is taking 18 minutes. For the next round, total she is taking 36 minutes, right? And then third round, total she is taking 54 minutes. So in this way she is going. Okay, so that means she will come to the starting point after every 18 minutes. So since one round she is taking 18, the next round total she is taking. So after every 18 minutes she is coming to the starting point. And for Ravi, Ravi is taking 12 minutes to drive one round. So first round Ravi is taking 12, then next round total he is taking 24, then third round he is taking 36 minutes in this way. So that means he will come to starting point after every 12 minutes. So therefore the LCM of 12 and 18 will give us the time they meet again at starting point. So since we can see that these are basically the multiples of each round, right? So the time taken for each round. So we need to find when they will be meet again, that will be the lowest common multiple. Okay. So now let us find the LCM of 18 and 12. So let us do the prime factorization of 18, that is 2 into 3 to the power 2, and 12 is 2 to the power 2 into 3. So LCM will be the factors with the highest power. So 2 to the power 2 into 3 to the power 2. So that is equal to 36. So in 36 minutes, Sonia arrived at the starting point after making 2 rounds, while in 36 minutes, Ravi arrived at the same starting point after making 3 rounds. Okay. So in this case, Sonia is taking, after 36 minutes, Sonia is making 2 rounds, and for Ravi, he is making 3 rounds. So hence they meet each other at the starting point after 36 minutes. So that's all for today. So hope you understood this video completely. So if you like my video, please hit the like button. And if you have any comments, you can put it in the comment section. And please do share this with your friends. And to get upcoming videos notification, please do subscribe in my channel. For that, you just press the bell icon and you will be get notified for the upcoming videos. That's all for today. Thank you. Bye bye.